Dave Soriano, Chem Professor with the University of Pittsburgh, Bradford, in Bradford, Pennsylvania. And this is a lecture which I'm uploading to YouTube from a course I teach, Introduction to Biofuels. And this section deals with next generation feedstocks and introduction. Feedstocks, biomass that can be converted into liquid fuels. Second generation feedstocks, well, that would include cellulosic biomass such as wood, tall grasses, forestry, and crop residues. They're expected to expand significantly the types of biofuels over the next 10 to 15 years. New conversion technologies will focus on low-cost residues and waste sources of cellulosic biomass. Waste biomass creates value for society and cuts down on fossil fuel use. The material would otherwise decompose back into carbon dioxide. No additional land is needed for production. Fast-growing perennial energy crops, example short rotation woody crops or tall grass crops, can be grown on a wide range of soil types, and the extensive root systems prevent erosion. High-yield biomass, however, will only be achieved on good soils with sufficient water supplies. Cellulosic biomass is more difficult to break down and convert to liquid fuels as opposed to, let's say, sugarcane. But this tenacity can also be great for storage. You see, in an earlier lecture, I pointed out that sugarcane, when harvested, must be processed within 24 to 48 hours. Perennial energy crops can supply much more biomass per hectare since all of the plant is used. Compare this with oilseed crops and some starch sources that I've mentioned outlined in earlier lecture. Basic characteristics of cellulose biomass. Three primary components: cellulose, hemicellulose, and lignin. Cellulose is basically a polyglucose, very similar to starch, except it's a different anomeric or different construction. We don't have the enzymes, humans, to break it down as a foodstuff. Hemicellulose, that's short chains of 5 to 6 sugars, easier to break down. And then the lignin, that should be lignin, which is a polyaromatic resin and serves as a connective tissue, and that's why we have trees. Without lignin, we would simply have on our planet grasses. Cellulosic biomass, typical range 40 to 55% cellulose, 20 to 40% hemicellulose, 10 to 25% lignin. We refer to the typical plant materials as lignocellulosic. Different technologies for producing biofuels from cellulosics use different components of the biomass. Enzyme technology focuses on the cellulose-hemicellulose conversion ethanol. Lignin is considered a good boiler fuel or feedstock for production of chemicals, fuel additives, or bioproducts such as adhesives. Gasification systems use a gasifier to convert all three components to syngas, which can make liquid fuels such as gasoline or petroleum. Here we see second-generation feedstocks: poplar, switchgrass, bamboo, sugarcane bagasse, hardwood, miscanthus, softwood, corn stover, sweet sorghum. Here we see the cellulose percentages, hemicellulose percentages, and lignin. Thank you very much for listening to this short lecture. Please look for other lectures that we have uploaded to YouTube on this subject.